Hi, today we're going to be talking about adding and subtracting radical numbers or radicals or square roots. And that's our goal for today. That's our objective. I can add and subtract radicals. What you'll need to do is get out a piece of paper, a pencil, and a calculator. So you can go ahead and take some notes and go ahead and pause this at any time and go back through it again if you are confused on anything. But make sure you take your own personal notes. So our agenda today, we're going to be going over adding and subtracting radicals, and then at the end, we're also going to be having some practice problems with some answers to make sure you're doing it correctly. So if we look at the first example, we have it up here where we have 7 square root of 7 plus 9 square roots of 7. And the way that we add these together is we want to look underneath the radicand to find the radical. That's what these are. So radicand is the square root. Radicand is the 7, and we want to see and make sure that underneath the square root sign both of the numbers are exactly the same. Are they exactly the same? Here's a 7, there is a 7, so yes. And then what we can do is add the front numbers. We can say 7 plus 9, and then we can go ahead and get the final answer. So 7 plus 9 is 16. So see how we added the front numbers as our final answer, and then we still have that square root of 7. So here is another example. We have 4 square roots of 2 plus 6 square roots of 2. And again, underneath the square root, they're both the same. We're going to add the front numbers together. So 4 plus 6, what is that? That is 10. And again, as you can see, it is square root of 2. Okay. Here is a different type of example. We have square root of 5 plus square root of 5, and what we need to remember is that we have where it is, we're looking at it and going, okay, how many square roots of 5 do we have? Well, the first one we have 1. How many square roots of 5 do we have in the second one? Well, there's 1. How many do we have total? So we have 1 square roots of 5 plus 1 square roots of 5. Okay, so remember that mathematicians don't write down ones. That's why I stuck a 1 in the front to kind of remind me, oh, I have 1 square root of 5. I have another square root of 5. Well, how many square roots of 5 do I have? I have 2 of them. And then I write the final answer as 2 square roots of 5. So here we're looking at another example. So we have 5 square roots of 3 plus 5 square roots of 2. And so these are a little bit different. Underneath the square root sign, we have 2 different numbers. And then the other question that we need to ask ourselves is, okay, are these simplified as much as possible? And these are simplified as much as possible. And can we add these together? No, we cannot. So because they are not the same underneath the square root sign, we're just going to leave the final answer as 5 square roots of 3 plus 5 square roots of 2. Because we cannot add these 2 together, because underneath the square root sign, there are 2 different numbers. The next example, we have square root of 75 plus 6 square roots of 12. So before we try to go ahead and add these together, we're going to go ahead and look at the numbers underneath the square root sign. Is this simplified as much as possible? And the answer is no. And so remember, when we did our simplifying radicals, we were looking at the perfect squares. And we need numbers that will multiply together that will be 75. So I personally know that 3 times 25 makes 75. So we have 3 times 25 equals to 75. And notice how I put them underneath their own square root. Okay. And then I want to go ahead and I want to go, okay, can I take the square root of 3 using my perfect squares or my square roots list and get a whole number? The answer is no. Because if we look at, there's not a 3 in here, so it goes 1 and then 4. Or there's not a square root in here. And then we have 25. Well, can we take the square root of 25? So the square root of 25 is 5. Because if we look at our perfect squares, we have 5 squared equals 25. So remember, square root is the opposite of the squares. Okay. So then we can go ahead and now write this as 3 square roots of 5. And then mathematicians love having it so that the whole number is in the front and then the square root stuff is in the back. So I just put this in the front. So it's still 5 square roots of 3. Now let's look at the 6 and kind of what's going on. So we're adding. So here we're still adding. Okay, and we are having where we have this 6 that's on the outside. Well, we still have that, so we're still going to kind of write down that 6 that's on the outside. He just kind of stays there for a little bit. And then again, we want to go ahead and look at the 12. We want to factor the 12 into smaller things, and we kind of want numbers that come from the perfect squares list. So I know that I can take 12 and do it as 3 times 4. And again, notice how I did it as the square root of 3 times the square root of 4, because the 12 was underneath the square root sign in the first place. And then we want to look at it and go, okay, can I take the square root of 3 and get a whole number? Well, is that part of the perfect squares list? Unfortunately, it's not, so we're just going to leave it the way it is. Then I'm going to look at the square root of 4. Can I take the square root of 4 and get something, is it on the perfect squares list? And can I get a whole number? Yes, the square root of 4 is 2. And so if we look at it now, we now have 6 square roots of 3 times 2. And again, mathematicians, so 6 square roots of 3 times 2, mathematicians like to put the whole numbers first, so 6, and then we put the 2 in the front, so they like to be in the front, and then we still have the square roots of 3. And we are still adding these, so that's kind of in the middle. And what we want to do is we want to simplify our numbers as much as possible, so let's look at the 5 square roots of 3. Can I multiply anything together on the front? No, it's pretty much how it is, so we're going to leave that there. We're still adding. Now let's look at the 6 times 2. Can we simplify this more? Yes, I can. So 6 times 2 is 12. And then we still have the square root of 3 that's along with it. Now let's look at them and say, okay, can I add them together? So I have a 3 underneath the square root sign. I have a 3 underneath the square root sign. I can add these together. So we're going to say 5 plus 12. Well, what is that? 5 plus 12 is 17. Square root of 3 still stays there. So then this is our final answer of 17 square roots of 3.